Alright, hello. In this video, we'll be talking about chain rule. Okay, in the previous video, we talked about the power rule, the product rule, and the quotient rule. As a reminder, the power rule is anything to the nth power. We just move the n to the front, and then the variable to the n minus 1th power. Product rule, if we have two terms multiplying each other, it will be the derivative of the first term times the second term plus the first term times the derivative of the second term. Quotient rule is something similar. First term over second term, f of x divided by g of x will become derivative of f of x times g of x minus f of x times the derivative of g of x over g of x squared. Alright, now let's talk about the new rule, chain rule. Now chain rule is, rather than a formula, it's more like a concept. So chain rule says if you have f of g of x and you're trying to take the derivative of that, d over dx. If you're trying to take the derivative of this will become f prime of g of x. F prime of g of x times g of x. So what this is saying is you take the derivative of the outside component f of x while leaving the g of x alone. And then, I forgot, this is g prime of x. I'm sorry. This is g prime of x. Right. So you take derivative of the f prime, the outermost, the biggest part, in wrapping everything in. You take f of x and you take the derivative of that while keeping g of x the same inside. Then you multiply it by the derivative of g of x. Let's take a look at some examples. Obviously, if you haven't wrote all these other rules down, you'll need it because we're doing a lot of practice problems today. So this is just a rule, and I will be doing a lot of practice problems so that we make sure you know how to use this rule. And if you want to work along, just search up chain rule worksheet, and it should be one of the first few links. It's this one, and it will look like this. All right. So chain rule practice. Let's write our rule on the top again. So we have f of g of x. F of g of x. The derivative of that will be f prime of g of x times g prime of x. Alright, let's first start. So in this problem, we can see that this is the power rule. How? We can treat this entire thing like a variable. So our power rule, is that power rule? Yes, our power rule says x to the n. So now what if we replace x with this entire thing? So instead of x to the n, we now have 5x to the 4 plus 1 to the n, and n in this case is 2. Okay, now in this case, our g of x, which is the inside component, the smaller component, will be equal to 5x4 plus 1. F of g of x, that's g of x. Now the f of x will be simply x squared. Okay? F of x is x squared, and x is g of x. G of x is the inside component, which is 5x4 plus 1. F of x is going to be squaring this entire thing, and f of x is just x squared, which is g of x. And this, you should have learned in this pre-calc how this works. So this will be just, so f of, now when we write it like this, f of g of x, we will now replace this x with our g of x. So f of the g of x will be 5x4 plus 1. Okay, so now that you know what g of x and f of x are, let me erase all this. I start working problem. The formula says we first take the derivative of f of x. We know that f of x is x squared, so it will just be 2x1 using power rule, 2x. But our x is not x, as written over here, it is g of x. So we replace x with g of x, and our g of x is 5x4 plus 1. Okay, now we're not done. We have to take the derivative of the inside, which is the g of x now. And this is multiplied by derivative of this. We just use power rule again. Drop the 4 times 5 is 20. 20x to the third. Plus 1, derivative of a constant is 0, so just plus 0. And now we have 20x cubed, so this will be 40x cubed times 5x to the 4th power plus 1. Let me see if I forgot anything. Okay, yeah, okay. One thing that you need to know is that when you're taking the derivative of let's say this, right? You're trying to take the derivative of 5x4 plus 1. When you're having two terms, you can take the derivative of each term separately. So you can take the derivative of this plus the derivative of that, and you add it in. I think I might have forgot to explain that in the previous video. So now, yep, this is the first problem is done. So you first figure out what g of x is, and then take the derivative of the outside, which is the square part, drop the 2, and treat this entire thing as g of x alone, and leave the g of x here. Alright, let's go on the second problem. So this is basically y equals negative x cubed minus 4 to the 1/5 power. Okay, now this, we're going to have to use some power rule again. First, we treat this as g of x, so we take the derivative of this entire thing to the 1/5 power. We drop the 1/5 in front. This will become 1/5 times negative x cubed minus 4 to the negative 4/5 power. 1/5 minus 1 is negative 4/5. Okay, now we took the derivative of the outside. We take the derivative of the inside, which is g of x, which is multiplied by negative 3x to the second power minus 0, because the derivative constant is 0. So that's it. So we have negative 3x squared over 5. Okay, we can rewrite this as negative 3x squared, and anything to the negative power will just go into the denominator. So over 5 times negative x squared minus 4 to the 4/5 power. Next one, now this is product rule plus chain rule. So product rule, we treat this as f of x and this as g of x. So we have, let's use chain rule. So chain rule says we need to take the derivative of the first component, derivative of this, which is 20x fourth, times the normal of the second one, which is x plus 1 to the 1/3 power, plus normal of the first one times the derivative of the second one. So the derivative of this is x plus 1 to the 1/3 power. So now we move the 1/3 over here. We treat this thing as a g of x. So g of x, f of g of x, we first take the derivative of f of x with respect to g of x. So this should be 1/3 times x plus 1 to the negative 1/3 power. Nope, negative 2/3 power. Negative 2/3 power, 1/3 minus 1 is negative 2/3. So this can be rewritten as 1/3 times x plus 1 to the 2/3 power. Okay, now we took the derivative of the outside. We take the derivative of the inside, which is g of x, which is x plus 1. Now x plus 1, the derivative of x plus 1, derivative of x is 1. 1 plus the derivative of 1, which is 0. So 1 plus 0 is 1. So we basically multiply this by 1, which we don't need to do anything about it. So this problem will be the exact same answer whether you use chain rule or not, because the chain rule inside happens to be x plus 1. So this will be 1/3 x plus 1 to the 2/3 power. Alright, number 4. This is the same thing. We're going to use product rule again. So first, take the derivative of the first part, derivative of this. In the previous video, I showed you that square root of x, the derivative of that is just 1/2 square root of x. Alright, so now we can use this exact same thing, and instead of x, we just replace x with this giant thing. Okay, so now we know that this derivative of this, without using chain rule for now, will be equal to 1/2 square root of negative x fourth minus 1. Okay, that is without chain rule. Obviously, we're not done here, which means we have to, because we still have to use chain rule. So now this has to be multiplied by the derivative of g of x, which is the inside, which is negative x fourth minus 1 will be, let's erase top, which means this will be multiplied by negative 4x cubed minus 0. Okay, that's the first term, times the normal of the second term, negative x minus 2, plus the normal of the first term, negative x fourth minus 1 to the 1/2 power, times the derivative of the second term. Derivative of this is just negative 1 minus 0, so it's just negative 1. So it's basically multiplying this by negative 1, and we can rewrite this by simply changing this plus sign to a negative sign. Alright, look at the answer key right now to see if I did anything wrong. X plus 1 squared. What happened to x plus 1 squared? Okay, the answer key is the same thing. The answer key just simplified it. By the way, the answer is on the bottom. The answer key just simplified it, which we will not be doing because you're not expected to simplify your answer on free response questions. We won't bother wasting time. If you're misbolding, you know, we won't waste time in class simplifying answers. Okay, except for MCQ. MCQ is different. You gotta know how to simplify it or else the answer you're looking for might not be there. All right, number 5. Product rule again. We have derivative of the first term. 3x minus 1 is just 3. We don't need to use chain rule on this term because it just simply itself. It's not being, the g of x, which is this, is not being manipulated in any way or form. So it's just 3 times the normal of the second term plus the derivative, no, plus the normal of the first term, 3x minus 1, times the derivative of the second term. Now let's take the derivative of this. We use power rule to bring this negative 3 down. It'll be negative 3 times negative 3 to the x squared minus 4 to the negative 4th power. Negative 3 minus 1, negative 4. Okay, now that's only the first part. We still got to take the derivative of g of x, which in this case will be this inside thing, which is negative 3x squared minus 4. So when we take the derivative of this, will be negative 6x minus 0, because derivative constant is 0. So this will be this thing. Oh, I lied. It will be this multiplied by negative 6x. So we took the derivative with respect of f of x, or with respect to g of x, and now we take the derivative of the inside, the g of x, which is negative 6x. So the final answer will be 3 times negative 3x squared minus 4 to the negative 3rd power plus 3x minus 1 times all this. And let me check the answer key. 3x minus 1 times negative 3x squared minus 4 times 6x plus 3 times, yep, that's alright. Alright, number 6. Okay, now we first treat this, the inside, as g of x. So let's use power rule to take f prime of x with respect to g of x. Let's treat this entire thing as g of x for now. So this will be 3, we pull the 3 down, 5x, we leave everything in there alone, minus 3, because with respect to g of x, cubed plus 1. Now we put 3 minus 1, which is 2 on top. Alright, now we multiply by the derivative of g of x, which is the derivative of everything inside. Okay, now with the derivative of everything inside, we need to use quotient rule now. So first, derivative of the top will be 25x fourth, power rule, minus 0, we don't try that, times the normal of the bottom. I'm out of room. Okay, so let me just rewrite this over here. So this is multiplied by 25x to the fourth times negative 3x cubed plus 1. Okay, now we have, and then we need to multiply by, let me erase all this first. Okay, now we keep the top the same, which is 5x cubed, 5x to the 5th power minus 3 times the derivative of the bottom, which this will be negative 9x squared plus 1, which derivative of 1 is 0. So this is everything on top, oh, and the minus sign in between, over the bottom squared, negative 3x cubed plus 1 squared. This is using quotient rule on the inside g of x. So the answer is going to be 3 to the 5x to the 5th minus 3 over 3x cubed plus 1 to the 2nd power multiplied by all this. Alright, wait, did I forget something? Does seem like I did. Yeah, I should be fine. Okay, next one, it's the same thing. We first take derivative of f of x with respect to g of x. G of x will be the inside, so 1/5 times x fifth plus 4 over x squared minus 5 to the negative 4/5 power. Okay, we left g of x the same inside. Now we want to multiply by this by derivative of g of x. G of x is using quotient rule again. So this will be derivative of the top, 5x fourth, 5x to the 4th, 5x to the 4th, times the derivative, times the normal of the bottom, minus the derivative, let me draw a giant bracket here, minus the derivative of, minus, keep it the top the same, x5 plus 4 times the derivative of the bottom, which would be 2x, all over x squared minus 5 squared. And that's it. Take the derivative of f of x with respect to g of x. And f of x in this case will be x to the 1/2. With respect to g of x means we replace this x with g of x, which is everything inside. And then we take the derivative of g of x, which is using quotient rule. We get all this. Alright, number 8. Number 8 we have, this time is using quotient rule. Okay, so quotient rule, this time, this giant thing is going to be a quotient rule. So quotient rule means we take derivative of the top. Derivative of the top is x squared minus 3 to the 1/5 power. So we pull the 1/5 down, it will become 4/5, negative 4/5 on top. Okay, that's the derivative of the top times, oh, we forgot the chain rule. The chain rule, we took the derivative of the outside with respect to the g of x. Now we take the derivative of g of x. See how I almost forgot? Okay, yeah. On exams and stuff, it's really easy to forget to use chain rule, and I've done it on the AP exam, I'm sure. Okay, so now we need to remember to use chain rule by multiplying this by 2x. We take the derivative of the inside, x squared minus 3, derivative of that is 2x. Okay, and then, okay, that's the top times the normal of the bottom. We're doing number 8, by the way. We times the normal of the bottom, which is negative x minus 5. Negative x minus 5. Minus the derivative, I'll keep the top the same this time. So the top is x squared minus 3 to the 1/2 power, 1/5 power, times the derivative of the bottom. Derivative of the bottom, thankfully this time is much easier to do because negative x minus 5, derivative of that is just simply negative 1. The coefficient is negative 1 for the x. So instead of multiplying this by negative 1, we can just simply rewrite this as a plus. Now we need to divide this entire thing, because quotient rule, to negative x minus 5 squared. So this thing, number 7 was a problem where we used quotient rule inside of chain rule. Now this one, number 8, we were using a chain rule inside of a quotient rule, because we had to change the first part. When we were trying to find the derivative of the upper component, we had to use chain rule, but everything else was just quotient rule. Number 9, secant. I have not taught you guys the trig identities for derivatives, and which I'm going to talk about in the next video. And after I explain that, we can come back to do these remaining practice problems. If you have any question on how what do you call it, chain rule, if you have any questions on how chain rule works, you can let me know, or you can let me know in the comments. Thank you for watching.